Throughout history, military conflicts have driven some of the greatest technological advancements. One such innovation, frequency hopping, was originally designed for secure military communication and has since revolutionized modern wireless systems. In this video, we explore the fascinating history and technical workings of frequency hopping and how it continues to shape the world of communication today. Frequency hopping is a method of transmitting radio signals by quickly switching the carrier frequency between multiple distinct frequencies within a wide bandwidth. Both the transmitter and receiver change frequencies in a synchronized pattern, hopping hundreds or even thousands of times per second. This technique is part of what we call spread spectrum communication. The signal is spread across multiple frequencies over a short time, making it highly secure and resistant to interference. The story of frequency hopping begins during the height of World War II. In 1941, actress and inventor Hedy Lamarr, alongside composer George Antheil, developed a system that used frequency hopping to make military radio transmissions resistant to jamming by enemy forces. Their idea was to use rapidly changing frequencies to control Allied torpedoes, preventing the enemy from interfering with their signals. Though their system was not implemented during the war, the concept laid the groundwork for the frequency hopping technology we use today. Lamarr and Antheil's invention was one of the earliest examples of spread spectrum communication, now a cornerstone of secure military and civilian communications. Frequency hopping works by constantly changing the frequency at which a signal is transmitted. The transmitter and receiver both follow a predetermined pattern of frequency changes, which is known only to them. This synchronized hopping makes it difficult for adversaries to follow or jam the signal. Even if one frequency is jammed or intercepted, the signal quickly moves to another, making the transmission much more secure. Frequency hopping offers several significant advantages in communication technology. First, it provides anti-jamming capabilities. Since the signal moves across multiple frequencies, it's nearly impossible for an attacker to jam all frequencies simultaneously. Second, it enhances security. The only way to decode a frequency hopping signal is to know the exact sequence of frequency changes. Without that knowledge, eavesdropping becomes nearly impossible. Lastly, it offers interference resistance. By constantly moving across the spectrum, frequency hopping minimizes interference from other devices, ensuring a more reliable signal. Since its inception, frequency hopping has played a crucial role in military communications. Systems like SINCGARS, the single-channel ground and airborne radio system, use frequency hopping to ensure secure, jam-resistant communication between ground troops, vehicles, and aircraft. In a battlefield environment, this capability can be the difference between success and failure. By switching frequencies constantly, SINCGARS and similar systems maintain uninterrupted communication, even in the face of enemy jamming attempts. Although initially developed for military use, frequency hopping has found its way into many commercial technologies. Bluetooth, a common technology used for short-range communication between devices, relies on frequency hopping to avoid interference from other signals in the crowded 2.4 GHz band. Similarly, some Wi-Fi systems use frequency hopping to ensure clear communication in environments with many overlapping signals, such as crowded urban areas or office buildings. The impact of frequency hopping extends far beyond its technical advantages. What began as a wartime innovation has become a fundamental aspect of secure communication across industries. From safeguarding military operations to improving the reliability of consumer devices, frequency hopping represents a key milestone in the history of communication technology. As we move further into the age of interconnected devices, frequency hopping remains essential to preventing jamming, eavesdropping, and interference. Looking ahead, frequency hopping will continue to be an important tool in the development of secure, resilient communication technologies. With the rise of 5G networks and the Internet of Things, where billions of devices communicate wirelessly, frequency hopping will ensure that these devices remain secure and interference-free. Whether in military operations or the world of consumer electronics, frequency hopping will remain a crucial technique for protecting and optimizing wireless communication. From its origins in World War II to its critical role in modern technology, frequency hopping has changed the way we communicate. It's a reminder that some of the most impactful innovations often come from times of conflict, only to evolve into solutions that shape our everyday lives. As engineers and history lovers, we can appreciate how this technology continues to evolve, ensuring that our communications, whether on the battlefield or in our homes, are secure, reliable, and resilient.